Hello friend, welcome to my YouTube channel Mechanical Design Adda. So in this video we will discuss what is meant by spring, the principle behind the working of the spring we will discuss, and also we will discuss mostly on the type of the spring and its applications, and also further we will discuss the spring material and its advantage and the disadvantage. So let's start. What is mean by spring? So the spring is a mechanical component which store the energy during the expansion. So the expansion we can say it may be the compression or stretching or the tension or the twisting. So during the expansion the spring stored the energy, and after the releasing of the force, the spring take its original shape and the size and releases the energy. Okay, so here I'll take the highlighter. Okay, so the springs is elastic components also. Okay, so they can return to their original shape after being deformed. Okay, so whenever we are applying the force or any load on the spring, so at that time the spring is deformed, and after releasing the force, so the spring return to its original shape and take its original shape and the size. So here you can see this one is a tension spring. So we are applying here the we are stretching the spring here on this side, and this one is a compression spring. So we are applying the compression force. Okay, so here, so in this in this type of spring, the spring is reducing its length, and the tension spring, it is increasing the length. So here this is the torsion spring. So here we are applying the both the side from this side we are applying the force, and from this side also we are applying the force simultaneously. So this spring is in the twisting. So the deformation of the spring is like it will it will stretch, compress, or it may be twist. Okay, and this is the type of spiral spring. So these are having the special applications like in the watches. Okay, and here we can see on the battery side, so we have in the remote, like we can see this type of springs in the remotes. So these are the compression spring. Okay, so compression spring we use in the remotes and all these things. Okay, so these springs generally work on the principle of the Hooke's law. Okay, so let's discuss this Hooke's law in detail. Okay, so here we can see the principle of the spring. So the springs is generally works on the Hooke's law, and the Hooke's law is based on the force and the displacement. Okay, so this one is the force, and the increase and the decrease of this length is the displacement. Okay, so here we can see mathematically F is equal to minus K into X. So this is the Hooke's law, means where we have the force is directly proportional to the displacement. So here we are applying the force and we are getting the displacement. Suppose I increase the force by 2 times, then the displacement also it will increase. And after releasing the force, it will take its original shape and the size. So because this springs is elastic component, so it will regain its shape and size. So the F is equal to minus K into X, where F is a force applied on the spring, and the X is the displacement of the spring, and the K is nothing but the spring constant. And here minus sign we are applying because, so here on this direction we are force are applying, but due to the elastic property of the spring experience the restoring force on the spring. So that restoring force is in the opposite direction of the force. So that's why it is minus sign is given here. Okay, so the K represent the stiffness of the spring. Okay, so how stiff this spring is there. So that stiffness is generally based on the material of the spring. Okay, so here the springs are divided into four categories, like helical spring, leaf spring, disc spring, and the special purpose spring. Okay, so there are the different types of the helical spring, leaf spring, disc spring, and the special purpose spring. So let's discuss. So here we can see the different type of helical springs are there. So compression spring is there, extension spring or tension spring, and the torsion spring is there, and the spiral springs is there. Okay, so the compression spring, generally we can see this type of spring in the two-wheeler suspension and in the IC engine. Also this compression spring you can see in the ball peen and the ball and the suspension. So, and the extension spring generally or we can call it as a tension spring. So the tension springs is generally used in the pull lever, jaw, and the wetting machines. Okay, and the torsion spring, so this type of springs generally we use in the door system and the clipboard. Okay, so here the torsion spring is attached to two different components using its two end. Okay, so here from two end we are applying the force and twisting the spring, okay, to keep the component apart at the angle. So these two ends are at the angle. So these springs are radically direction when the force is acting radically due to the rotation. Okay, so this type of springs we can see in the different components we are having where we are applying the at the two side force. Okay, like in the door system and the clipboard we can see. So where in the door system we can keep one end as a fix and other end we can applying the force. Okay, and the spiral spring, so the spiral spring generally we use in the watches, toys, and the seat recliners. Okay, now here let's discuss the different type of leaf spring. So the leaf springs generally they are having the 5 types based on the full elliptical leaf spring. So here we can see on here the complete shape is look like elliptical, that's why the name is given full elliptical leaf spring. So the leaf spring having the rectangular metal plates stacked together with the help of bolt and the nut. Okay, so this type is a full elliptical spring, and after that it is divided into three quarter elliptical spring having the upper portion is the half one only with the support of from the chassis frame. Okay, and the semi elliptical leaf springs having the bottom portion of the leaves are there. From the bottom only we have the leaf arrangement and all the rectangular metal plates stacked together on the bottom side only, and the quarter elliptical leaf spring is the thing but the from the upper side, but it is a half portion. So here you can see full elliptical spring and it is the one half of this portion. Okay, so it is a quarter elliptical leaf spring. And transfer leaf spring is from the above side only, it is the reverse of semi elliptical leaf spring. So it is from the above only we have the this different metal plates stacked together on the above side. Okay, so this one is the transfer leaf spring. Okay, so this leaf springs made up of the several strip of metal curved slightly upward and clamped together on the top of each other. Okay, and it is a simple form of spring commonly used in the suspension in the wheel vehicle. So this type of the leaf springs we can see in the heavy duty vehicles for heavy duty vehicle suspension. So we can see this type of spring. Okay, Next one is the type of the disc spring. So here we can see the different types of the disc springs are there. Okay, so this disc spring we use for to absorb the high load. Okay, to absorb the high load in the tight space. Suppose we have the minimum space, but so at that time we can think of the disc spring. So because in the because it consume the very less space because of its shape, and but with this consuming less space, and it absorb the high load. Okay, so bevelin spring, spot disc spring, contact disc spring, and the core spring, and the wave spring, and the finger spring. These are the 6 type of the disc springs are there. So generally beveling springs we use in the tightening the bolt. So where we have this type of the beveling springs we use. Okay, so at that time it can absorb the high load. So here is the special purpose spring. So like variable rate spring we can see here. So here we have the different pitch between the two coils. So and also we have the flat spring. So here we can see the zigzag portion having the flat portion. So this type of spring is called as flat spring. This one is a machine spring, and this one is a molded spring. So plastic springs are there, having the complete molded springs are there. Okay, and the next one is the serpentine spring. So this is a serpentine spring. So this one is a gas spring, and the next one is the balance spring. So these are the special purpose springs where for the special applications we use this type of spring. On the material, so there are different material, from the different material we can make the spring. So in that, the copper alloy, ceramic, and the rubber, and the glass fiber composite material, and the steel alloy. So these are the different type of material we can use to make the spring. So generally for the metal spring we use the steel alloy commonly. Okay, and regarding the advantage and the disadvantage of the spring, so the advantage of the spring, like it is having the better shock absorbing capacity, and also it will store the energy, and also we can use this spring for the joining mechanism and the product stability. Okay, so and the disadvantage of the springs are like it is it is expensive in some of the machineries, and they lose their effects over the time, because eventually it will fail the obey Hooke's law. It will not return to its original shape means after the deformation. So sometime it will lose the elasticity after the long duration of run. So this is the few advantage, but we can replace the spring whenever we want. Okay, so that's it from this video, friend. If you like this video, please like, share, and subscribe the channel, and hit the bell icon so that you will not miss the videos from Mechanical Design Adda. Thank you for watching. See you in the next video.